are going to be used to solve logarithmic expressions, and we are also going to do some equations later today, and then we're going to translate that says between logs with any base. So I know in this class specifically you guys were asking me how you can do logs on the calculator because it has the log base 10. So we're going to learn some strategies for that today. Okay, so the three properties we're going to learn, it's called the product, the quotient, and the power. So just based on the name alone, if it's called the product property, what do you think it's going to have in it? Yeah, multiplication. You guys remember the quotient? The quotient is division, and then the power is going to have an exponent, and then something special will happen with the exponent. So remember that logarithms are properties, are functions that use exponents. Okay, so you can derive the properties of logarithms from the properties of exponents. And when you are multiplying variables with the same base, do you guys know the answer to that? When you're multiplying with the same base, what you have to do? Yes, good. Okay, when you multiply variables with the same base, you add the exponents. So this says observe, and we're actually going to observe a couple of things here. Okay, so if you have a to the third times a to the fourth, that would be a to the what? Yep, because you could do 3 plus 4, which would be a to the 7th. Okay, so that's when you are multiplying with the same base. Okay, let's also look at what happens when you do a power to a power. So this is when you multiply variables with the same base. Okay, if you do a power to a power, sometimes these get confused for each other, which is why I want to show you this. This would be a cubed to the fourth. Do you guys remember what you do to exponents then? Yeah, that's when you multiply. So that would be a to the 12th. So we're going to use both of those today. Okay? All right, so the first thing we're going to talk about is the product property. So this is log base b of m times n. So this is a way that you can split these when you have the product. You can rewrite this as the log base b of m plus the log base b of n. So the logarithm of a product is equal to the sum of the logarithms of its factors. Okay, so this is going to be the sum of the logarithms of the two factors. So let's look at an example. Let's say you have log base 3 of 1,000. Okay, so you have log base 3 of 1,000. One way that you could rewrite this is log base 3 of 10 times 100. And we're going to do 2 in this thing, so for spacing purposes, keep it like that. Okay, and then you could rewrite this as log base 3 of 10 plus log base 3 of 100. And sometimes they will just have you expand the log like that. Other times you can simplify it. So let's say it wasn't log base 3. Let's just say it was the log of 1,000. Remember, the common log has the base of what? 10. So this is, we could split this up into the log of 10 plus the log of 100, just like we did before, okay? I just didn't write that first step down. And then you could actually simplify that, right? If you have the log of 10, do you guys remember how we simplify that part? We'll put a little note up there. So log base 10, you'd be asking yourself 10 to what power is 10? What is the answer to log base 10? 1. What about log base 100? Yeah, because 10 squared is 100, right? This is like 10 to what power is 100? Your x equals 2. Okay, so then your final answer for this, when you have to simplify, would be 3. Now technically you could do that even here, right? 10 to what power is 1,000? We learned how to do that. Okay, this is just another way to break it up into more manageable pieces. Okay, another tool in our toolbox. All right, now let's look at the quotient property. So you guys already told me, yep, that's going to have to do with division. So if you're dividing these, do you guys remember the rules with exponents? If it's division, how you can rewrite them? Well, it does tell you in words, right? The logarithm of a quotient is the logarithm of the dividend minus the logarithm of the divisor. Okay, so remember when you have, like we did multiplication with addition, you have division and subtraction. So this is log base b of m minus log base b of n. Okay, so I'm going to give you the first part, and I want you to rewrite it. Simplify as much as you can. So log base 5 of 16 minus log base 5 of 2, and then can you rewrite that for me? So simplify as much as you can. Some of these you'll be able to simplify, other ones you won't be able to simplify without a calculator. Okay, so if it's division, you're going to rewrite log base 5 of 16 over 2, and then what is 16 over 2 reduced to? 8. Okay, so once we practice this, you're just going to jump to 8. For this, I am just going to show you the division part, so log base 5 of 8. Now, can I simplify that any further with mental math? Well, let's think about what the exponential function would be. It would be 5 to the x power equals 8. Is 5 to a whole number or a negative whole number going to be 8? No. Okay, so we can't solve that without a calculator, so we're going to leave it like this for now. All right, and then the power property. So the power property has to do with an exponent. If you have log base b of a, and it's raised to the power of p. I know there's a lot of letters in there. Okay, and we're going to rewrite that as p times log base b of a. So really, what happens to that exponent? Where does it go? Yeah, it's just multiplied to the log, right? So it's just going to come down in front here and then be multiplied. So the logarithm of a power is the product of the exponent, okay, so that exponent comes in front, and the logarithm of the base. All right, so then let's try that with the log of 10 to the third power. So the first step would be to rewrite it as a product. So this would be 3 times the log of 10. Okay, does the log of 10 simplify? Yeah, what's the log of 10? 1. This is a special property because remember, if you have the same base and this, it makes 1. You can also think of it as 10 to the x equals 10, right? So this is going to simplify to 1. What's 3 times 1? 3. So this would be your final answer. Okay, and again, this is a special property. The log of 10 is going to be 1. All right, so now we're going to use these properties for example 1. Now, in the directions, you have to pay attention to what they're asking you for. So it is asking you to express this as a single log. So you are going to have to write down the single log, and then you're going to simplify if possible, and we'll go over what that looks like in terms of what your answer should be. Okay, so for part A, you have log base 6 of 4 plus log base 6 of 9. So now, according to our properties, we have the log base 6 of 4 times 9, which is what? What's 4 times 9? 36. Okay, so now you can ask yourself, okay, you can ask yourself, 6 to what power is 36? Yeah, what is it? 2. Okay, so then this is going to be equal to 2. Okay, so your answer would be, I'm going to change this, log base 6 of 36 equals 2. This would be your entire answer. Okay, so this is your single logarithm, and this is what it simplifies to. Okay. All right, so let's do B. Log base 4 of 2 plus log base 4 of 128. So really, you're multiplying what two things together here? Yeah, 2 and 128. So let's double that. Can we do that without a calculator? Double this? Okay, because what's double 28? You double 28, you get what? 56. So this is going to be 256, okay? So now, remember, you are asking yourself, when you're solving the logs, it's always 4 to what power equals 256. Now, I'm going to make it visible for you what I'm thinking. I'm thinking that 4 squared is what? 16, and we should all know that. Well, and we do. And then 4 cubed is what? 64. And if we don't know that, we can just do 16 times 4, right? That's how you get 64. Okay, so then I can do 64 times 4, which I would do this old school, right? 4 times 4 is 16, carry the 1, 24 plus 1. Okay, so 4 to the 4th is 256. So then this is going to be equal to 4. So then this would be your final answer. Log base 4 of 256 equals 4. Okay, see how this part here is exactly what you did in 4.3? Simplifying using the mental math. Okay, so the second part is something you've done before. Okay, why don't you try part C? So it's a minus, so that's going to be something. Alright, you guys look like you're doing well with the first step and then simplifying. So then once you get to log base 5 of 25, remember you're asking yourself 5 to what power is 25, and what is that? 2. So this is going to be log base 5 of 25 equals 2. Okay? And eventually this is just going to become second nature where you don't even have to write that part down. Okay? For some of you, you probably are already doing that, and that is fine. Okay, and then this one is going to be division as well. So we have log base 1/3, and yep, it's okay to have a fraction, of 27 divided by 9. 27 divided by 9 is what? Good. So log base 1/3 of 3. Now, when you get here and you set up the exponential function, 1/3 to the x power equals 3. Do you guys know what that is? Yeah, great. It's -1. Okay, because 1/3 to the -1, you have to use the what? The reciprocal. So if you flip it, it would be 3 to the first, which is 3. Yay! So this is going to equal -1. Okay, so your x is -1. That is your answer. Okay, just like that. How do we do? Pretty good? All right, let's take it to the back. All right, so on the back side, we're going to be expressing as a product. And then I'm also going to reveal a mathematical secret today. We'll unlock a mathematical secret. Maybe some of you already know it though. Okay, so we're going to express these as a product now and then simplify it as possible. So when you express as a product, I need to see the multiplication part. Remember that the exponent is what comes down in front. So this becomes 6 times log base 2 of 32. Okay, this is the product, so that's going to be part of your answer. Now when it says to simplify, what you're going to do is simplify this part. So remember, the answer to this is 2 to what power is 32? And what is that? Yes. So then what we're going to do is we're going to rewrite this as 5. So this becomes 6 times 5. Because log base 2 of 32 equals 5. So if you were to simplify this, okay, you would get 5. And now you can just multiply. Together it would make 30. So again, what we did is we simplified here. Okay, in this case it would be equal to 5, so then we just multiply it by the 6, which is in front. Okay, so your whole answer, when you're expressing it as a product, would be 6 times log base 2 of 32 equals 30. Okay, that would be the product and then the simplified answer. Okay, so can you guys write the first step for B? Okay, so your exponent's going to come in front, so 20 times log base 8 of 4. Now when you are simplifying this, again, you're thinking, okay, 8 to what power is 4? Notice that you have a number here as your base that is higher than this. Okay, so if we're doing this with mental math, I'm going to teach you how to rewrite this with the same base. Okay? Each one of these can be rewritten with a base of what? 2. So we're going to rewrite with the same base. Okay, rewrite with the same base. Okay, so 8 can be written as 2 to what power?
30.
Yep, so 2 to the 3rd, and then we're just going to keep the x here. 4 can be written as 2 squared. Now, I want you to think about why this works, okay? Once you have the same base, what do you know about your exponents? So this is an equation, right? Yes, we see the equal sign, it's an equation. Okay, so if you were to solve whatever you get here, okay, if this ended up being like 2 to the 6th power, could this be 2 to the 4th? Are those equal? 2 to the 6th can't be the same thing as 2 to the 4th, right? Right? 2 to the 4th is 16. 2 to the 6th is 64. Are those equal? No. But could I have 2 to the 4th equals 2 to the 4th? Yeah, so the exponents have to be what? The same. So if the exponents have to be the same, what you can do is take the exponents and do what with them? What can I do? No, if the bases are the same, what else has to be the same? Yeah, the exponents have to be the same. So the exponents are equal. So we're going to set them equal to each other. 3x equals 2, and then we're just going to solve for x. So if the bases are the same, the exponents have to be the same. So we can set them equal to each other and then solve. Okay, so x in this case would be 2/3. So then we're going to rewrite this. So 20 times log base 8 of 4 is going to be 20 times, what did we simplify log base 8 of 4 to? 2/3. So we're just going to plug in 2/3 for that. And then do you guys remember how to multiply a fraction by a whole number? Multiply the whole number by which part of the fraction? You multiply the whole number by the top or the bottom? Yeah, the numerator, because it's like there's a 1 underneath this, right? So this would be 40/3. Okay, so then your final answer for this would be 20 times the log base 8 of 4 equals 40/3. And that's one of the more difficult examples because you did have to solve there. But anytime you have a base, okay, that is larger than what it's equal to, you should have some type of fraction as your exponent. Okay? So fractional exponents, this is going to be our special note. This is going to be our secret math. Secrets of math revealed. But some of you might know it. X to the 1/2 power, do you guys know what that represents? Okay, then I will reveal. It is the square root of x. So whenever you have a fractional exponent, it does represent a root. Okay, so the 1/2 power equals a square root. And this happens for multiple exponents. If you have x to the 1/3 power, that's going to be the what? Yeah, the cube root. Okay, so the 1/2 power is the square root. The 1/3 power is the cube root. Okay. We can actually use that property to check this. If you wanted to check to make sure that that was the same, I'm going to show you how to do that. Just don't stress too much about it. So if I wanted to check to make sure 8 to the 2/3 was equal to 4, if I wanted to check to make sure that this was equal to 4, I could rewrite this. So isn't 2/3 the same thing as 2 times 1/3? Yes, you guys agree? Okay, so then if I rewrote this as the power of 1/3 to the second, which we'll do more of this later on, but I just want to show you how quick this can be. 8 to the 1/3 we just said is the cube root, right? What's the cube root of 8? 2. And then what's 2 squared? 4. Yeah, so that works. It's correct. Okay? You don't have to check those every time. I just wanted to show you a way that you can make sure that you did that right. Okay, that you did it correctly. You can also, for your no calculator section of your quiz, you couldn't do this, but when you're doing your homework, you could do 8 to the power of 2/3 in your calculator and make sure it was 4. Okay? All right, now we're going to learn how to simplify using inverses, which you're really going to like, and then the change of base formula, which is going to be something that we can do on our calculator. Okay? So the inverse, first we're going to go over the rules, and then I'm going to show you some examples. Okay, the inverse of a log that has base b is an exponential function with base b and vice versa. Okay, so the inverse of a log with base b is an exponential function with base b. Okay, so the log with base b and the exponential functions with base b, they're inverses. What do inverses do to each other? They undo that operation. So like multiplication, division, right? You use it to undo the other one. A lot of times people think of it as canceling out, right? When you divide something that's multiplied, it cancels out. So your solution, in this case, when they cancel out, you're going to see that you're going to be left with the exponent. And then the other case, you're going to be left with the number that you're taking the log of. So I'm going to show you an example of each of those. Okay, so the first one is if you have the log base b. So if you have log base b of b to the x power, remember that inverses undo each other. So what happens is the log base b and the base of b undo each other, and you're left with x, which is your exponent. Isn't that lovely that that happens? It's very similar to that log base 10 of 10. Cancels out to make 1. Okay, this cancels out, and you're just left with the exponent. Now, it also works the other way, because remember, multiplication undoes division, but division also undoes multiplication. So when you have b to the power of log base b of, I just used s again. If you have that, same thing happens where these undo each other. B and log base b cancel, and you would be left with x. Now in this case, x is just the number that you're taking the log of. Okay, so the base of an exponential function and a log base cancel out. The log base and the base of an exponential function cancel out. Okay, so that works both ways. So in example 3, when you're asked to simplify, you're just going to be doing a lot of canceling here. Okay, so if you have log base b, in this case b is 3, log base 3 of 3, all you're going to be left with is 11. Oh, and then we have to change d, so don't do that one. I'm changing that to, I want this to be your exponent, 25 plus x, like that. Okay, and then let's skip to c, because for c, you have 5 and log base 5. So that's another one where you can just cancel out 5 and log base 5, and you're going to be left with 10. Now for b, I can't cancel that out yet, but can I rewrite this with the base of 3? Yeah, so rewrite with the base of the log. 3 to what power is 81?
4.
Good. So it's 3 to the 4th. So then log base 3 and 3 cancel out, and now you're left with 4.
Well, like on a test where you can set it up like the normal way that you taught us to think it's in 4.3, would you want us to do it this way, or would you want us to do it like the normal way of solving that equation?
Really, if it was this, you could do it anyway. Okay. Yeah, like where you think of it as, 3 to what power is 81? Yep, you could do it either way. Yep, that's a good question. And then for 5, again, these are going to cancel out, and then you're just going to be left with 25 plus x. So I wanted to show you what it looked like when you do have a variable in your final answer. You don't have to do anything extra. It's just that's going to cancel, and you're going to be left with 25 plus x. Okay, did you guys understand what Ava was asking for this one? Like if you had it on a test, you guys know that this is base answer exponent, right? So you could set it up as 3 to the x equals 81 and you could solve that way. So either one of those would be fine. Okay, good. Other questions for me on that one? All right, let's talk change of base. So the change of base formula is how you can use your calculator to find logs that do not have a base of 10. Okay, because I know that we were talking about that in here. So the change of base formula says if you have a log base b of x, okay, then what you can do is you can rewrite this, and it's very common to rewrite it with the common log because that is what you have in your calculator. What you can do is the log of x divided by the log of b. Okay, so you can use the common log, and we'll practice this, so you can grab your calculator. You're going to do this with the calculator and without it. Okay, so you can rewrite with the common log. So remember, when I say common log, I mean what? Yeah, log what? Yep, log base 10. Okay, and then this is the definition, but we need to flip-flop these. So the definition is the log with base b of x is equivalent to the log of, this should say x, because x is going to go on top, divided by the log of base b. And the way that I remember that is that the base is on the bottom. That alliteration just helps me. Base on bottom. Okay, now what's really awesome about this rule is you can rewrite it with the common log, or you can rewrite with any base you want. So that's how we're going to do it without a calculator. Okay? So the definition is the log base b of x is equivalent to the log of x divided by the log of b. So that's the definition of the change of base formula. All right, so for example 4, it says evaluate. Whenever your directions say evaluate, do you know what your final answer should look like? X equals a what? It should always be some type of number, because a value is the main part of evaluate. Okay, so you want just one final value. And we're going to do this, like I said, with a calculator and without a calculator. Okay, so we'll do the with a calculator. Okay, and then without a calculator. Okay, so the with a calculator, we're just going to use that change of base formula. So this would be the log of 8 divided by the log of 32. When you do this on your calculator, the parenthesis automatically comes up. So it's going to be the log of 8, close your parenthesis, divided by the log of 32. Okay, so let's do that. Oh, I already did that. Okay, so the log of 8 divided by the log of 32. Okay, and that is going to be 0.6. Okay, and then you're just going to put that as your answer there. Now, if you're going to do it without a calculator, you need to change the base to something that you can rewrite 8 and 32 with. Okay, so what can we rewrite those with? Yeah, so we're going to rewrite with the same base. So we can rewrite both with a base of 2. So 2 to what power would be 8? Yeah, so So this would be log base 2 of 2 to the third over log base 2 of 2 to what power would be 32? 5. And then look, we're just going to use our special properties. What happens with log base 2 and 2? They cancel, so on the top you'd have 3, and log base 2 of 2 would cancel, and you'd have 5. So then you would have 3/5. Okay, so then I want you to do both of those with log base 9 of 27, okay? Both. Yep, so do it with the calculator and do it without a calculator. Alright, so let's see how we did. So when you do it with a calculator, you want to change it to the log of base 10. Okay, because you have log of 27 over log of 9. And then, yeah, so when you did the log base 27 divided by the log of 9, what'd you get? 1.5. Should be nice and even for that one. And then without a calc, and I would never give you one without a calc that wouldn't turn out nice. Okay, so you're going to rewrite those with the base of what? 3. So 3 to what power is 27? 3 to the third, and 3 to what power is 9? The second. Now see how I wrote these with the inside and those with the outside? Doesn't matter. Okay, so in both cases, these will cancel. You'll have, in this case, 3. That will cancel. You'll have 2. 3 over 2 is equivalent to 1/2.